Alright, so now that we've talked a little bit about functions and had some practice writing our own functions, we're going to switch gears slightly and talk about this idea of scope. So scope has to do with variables. Alright, so variable scope is the part of the program in which the variable may be accessed. So while you are writing these functions, you are creating many different scopes. A scope is sort of like a neighborhood. It's the neighborhood where that variable lives. So only within that neighborhood can you access the value that is stored inside of the variable. So it's important to pay attention to variable scope, especially as we begin to write functions in our code. Alright, so there's sort of two different types of variable scopes. There's a local variable scope. So local variables are variables that are specifically assigned inside of a function. Alright, so again, variables, you give them a value via an assignment statement. Variable name equals some value. So if that assignment statement for the variable happens inside of a function, we call that variable a local variable. It's local to that function. That function is that variable's neighborhood. You can only access the value that's stored inside that variable while you're inside that same function. So because of that, it's very possible that different functions in the same program might have local variables with the same name. Alright, we'll do an example of that so you can get an idea of what it looks like. And again, this is okay because a function cannot see other functions' local variables. So if you make a variable inside of a function, let's say you name it value, and then I make another function, I can make another variable called value, and those are two completely different variables because they have different scopes. So if the assignment statement happens inside of a function, that variable only lives in that function, and you might repeat that variable in another function, but that's a completely different variable. Alright, so here's why scope is important. So let's go ahead and just for demonstration purposes, I'm going to go ahead and run this code so you can see what's going on here. So I'm going to go ahead, take all this, make a new file, and again, be careful of those indents, right? So I'm going to go back through, do all these indents. Alright, I'm going to save it. Now, before I run it, I'm going to walk through what's going on here. So we have two function definitions. We have a main function definition, which we've talked about now. Most programs, you'll have a main function that sort of controls the flow of the program. And then you might have other functions as well, which main might call to sort of do smaller subtasks. And then at the very bottom, we call the main function. That's how we tell Python, all right, Python, now go ahead and run that code that I talked about earlier. So in this main function, I call getName, which is another function. GetName has one line of code. Name equals input into your name. This is the same input statement that we've used many times, right? It takes whatever the user types in on the keyboard, stores it into this variable name. Now, this variable name, since name gets its value inside of the getName function, that means this variable name's scope is local to getName, meaning the value that's stored in name only exists in this function getName. It does not exist anywhere else in our code. It's only local to that function. So then when we're back in main and we say, hey, print hello name, that is actually going to error because this variable name does not actually exist in our main function because name was defined in our getName function. So let's go ahead, run this code. Alright, it's asking for my name. I'm entering my name. and then we get an error message. Specifically, name is not defined. And again, that is because this line of code right here, Python does not know what name is. And again, the reason being is name is defined here, which means name is local to this function, getName. This value for name does not exist in any other function. So this main function, when I say, hey, use this variable name, it's not going to work because this variable name was defined in a completely different function. So this is why scope is important. You have to sort of keep track of where your variables live. So if we go back to those variable drawing diagrams, I recommend introducing sort of a new level when you're drawing those boxes. Right, so in this example, we have a variable whose name is name, and I realize it's a little bit confusing. The name of the variable is name itself. So this is a variable. And in this example, right, I typed my own name into that input statement. So in this example, this string is in it, my name. So again though, this name, we got it here. We got it inside of this getName function. So something you might want to start doing with your variable box drawing diagrams is to give them, their little neighborhood. This is the neighborhood where this variable lives. It lives in this function, getName. So I recommend starting to do this where you can have, different neighborhoods. Now again, neighborhoods, these are scopes for different variables in your function, and have one scope for each function that you have. So we have one scope for getName, one scope for main, right? Because those are the two function definitions that we have. And then inside of these two functions, we can keep track of what variables are created in those functions. Now, main doesn't actually create any new variables, right? There's no assignment statements in the main function, so there's nothing here. But getName, here's an assignment statement. It's whatever you type in here as the user from that input statement gets stored into this variable name. So again, this is why this line of code gives us that error message, because when Python is reading through this, it hits this line of code and it says, okay, I'm inside main right now. Hey main, tell me what this variable is. But that variable does not live here. So you're going to get an error message. So do pay attention to variable scope. Okay, so we talked about local variables, right? Local variables are variables where the assignment statement, where you are creating the variable, is made inside of a function definition. Let's now talk about sort of the opposite end of that, a global variable. So a global variable is accessible to all the functions in the program. It's a variable whose scope is global. It's the entire program. So this happens when a variable is created with an assignment statement outside of all of the function definitions. So this only happens if you make a variable outside of all function definitions. Then it's a global variable. The entire program can see it. So you might be thinking, well, why don't I just make every single variable a global variable, right? Because then I don't have to worry about can the function see or not. Well, global variables are actually generally discouraged, and it's for multiple reasons, but I'll highlight a couple of key ones. So the first reason why global variables are discouraged is because they actually make testing and debugging more difficult. Now this goes back to the idea of why creating functions helps making testing and debugging more simpler, right? So the reason why it's easier to test and debug when you have functions is because when you split up your code into smaller pieces, it's really easy to say, okay, the bug is isolated to this function, which is this, however many lines of code, which means I can now just look at these 4 or 5 lines of code right here inside this function. Now, if that function uses a global variable, that global variable might be defined somewhere completely else in the code, right? It might not be right in that function definition. It might be somewhere else in the code, because again, a global variable is a variable whose assignment statement is outside of functions. So maybe the bug is coming from whatever the value is in the global variable, but you're going to have a hard time finding that because right now you're just looking at this one individual function that uses that global variable. Another reason why global variables are discouraged, so like I mentioned before, one perk of using functions is that you can reuse functions in other pieces of code. If you use a global variable, it's much harder to do that, because if you have a function that uses a global variable, then not only do you have to move that function over to your new program that you're reusing it in, but you also then have to go and find wherever you define that global variable and move that over as well. And in general, they can just make the program more difficult to understand. So it's much easier to sort of keep track of why you have certain variables if you have smaller sort of pieces. If you keep everything isolated into smaller functions, it's much easier to keep track of, the variables that you just use in that function, versus if you have a bunch of global variables, you have to sort of keep all of those in mind every single time you look at any function in your code. So again, global variables generally discouraged for many reasons. That said, the time where you would use a global variable is if that variable is a constant. Alright, so we talked about constants last week. A constant is a variable whose value never changes. So global constants, meaning a variable that you define, you create an assignment statement for outside of any function definition, and it's a constant, so you're going to name it with all capital letters, and then you give it a value. This value never changes. That's the idea behind a constant. So a global constant's value won't be changed, so because of that, you actually avoid all of the issues that we just talked about with global variables. Right? So since constants don't change, there won't be any weird confusion about, oh, okay, this function just used this variable, well now I got to go find that variable and figure out what the value is. If it's a constant, you know immediately what that value is. Ounces per pound, that's 16. I know that already because that's how many ounces are in a pound. So again, global constants, those are okay, and they're encouraged. This is what you define at the top of your file before you write any function definition. So we kind of had some practice with that last week. It's just last week we just didn't use any functions yet. Couple other things to keep in mind about scope is if Python is told to use a variable while it's running code, it's going to first look locally to find the value. Meaning, if you're inside a function and you say, hey, tell me what value is, tell me what this variable value is, it's going to look for assignment statements for this variable value inside the function first. If it can't find any inside the function, if it can't find anything locally, it will then check globally. Alright, so here's an example of that. So say this is our program. This first line of code, this is an assignment statement, right? Variable name equals some value. That's an assignment statement. Since this assignment statement is not inside of a function definition, right? It's not indented under some def name whatever part. That is a global variable. The entire file can access it. Alright, so that first line of code, global variable. Then we hit a function definition. This function, its name is showNum. Inside showNum, there are two lines of code. First line of code is number equals 3. That is creating a local variable. This local variable number only exists in showNum, and then it prints number. And then bottom of the code, we have the function called a showNum. So let's go ahead and do a variable box drawing diagram of what this program is doing. So again, there's one function here. So we'll go ahead and draw the neighborhood for that function, right? The neighborhood, the scope of where all those variables in that function live. So this function is showNum. That's the function. And then we'll just say this entire thing is the program, right? So this would be global variables outside here. Alright, so running through the code, first line of code, number equals 10. This is a global variable because it's not inside of any function definition, so the entire file can see it. So I'm going to write that way out here in this global area. So I'm going to draw my little box. Here's number. This is my variable number, and I put 10 inside of it. Cool. Global variable, awesome, done. Alright, then we hit a function definition. Function definition has these two lines of code. They don't run yet though, right? It's just a function definition. It's just saying, hey Python, if I ever tell you to do this, then do these two lines of code. So we do these two, we see this is a function definition. Then we go down here, hit the function call. Cool. Now I'm actually going to run these two lines of code. So when this line of code is run, it creates an assignment statement, right? It creates a variable. An assignment statement creates this variable. This is a local variable because it's inside of a function definition. So since it's local, we're going to draw it in here, inside the showNum neighborhood. And its value is 3. So inside of this function, I then say, hey, go ahead and print number. Alright, so again, the rule is with scope. If you're inside of a function definition, which we are right here, right? This is inside of this function definition. Python will look for the value of this variable first locally. So we'll first look here, inside this local area. And since there is a variable named number here, it will use this value 3. So this code, when you run it, it will print the number 3. It will not print 10. And again, this is because of how scope works. It first looks locally, then it looks globally. Please do let me know if you have any questions about that. Again, for all of this stuff, I recommend writing some code, playing around with it. So if you want to write your own Python code like this, maybe write another function definition with the same variable and sort of play around with that, guess and check what it's going to do. But please do let me know if you have any questions.